Okay, and welcome back. So on this video, this was one of the assignments that you were given was to write single replacement reactions. You're looking at the activity series. I don't know what textbook, I just pulled this up. I'm not sure what textbook that is. Look at your chart that you have and determine whether or not these reactions occur. And then I'm adding one more extra and the fact that I want you to write the net ionic for these reactions. So let's just go ahead and get started. And I'm going to do just a few of these with you, and you can check to make sure that you are doing them correctly. So first off, we're just going to translate. So I have lead, and that is just Pb. And I have zinc acetate, so C2H3O2. And acetate has a 1- charge, and then again from our periodic table and things that you've been told, remember that zinc has a +2 charge on that. So we're going to go ahead, we're going to need 2 of the acetates. So now we're going to go ahead and predict our product on that, and so we're going to go to our table, and we need to see if lead is higher than zinc. Is lead higher than zinc? So, kind of hard to read the chart, but here's the chart I'm reading. Here's lead. Okay, here's zinc. Okay, lead and zinc. One's at the bottom, one's at the top. Lead is not higher than zinc. Okay, that means lead is not stronger than zinc. Lead is actually less than zinc. So in this case, this is where we're going to put there is no reaction that occurs. Nothing's going to happen. Okay, zinc is not, or lead is not strong enough to knock off zinc. So that's an easy one. So the next one, we have iron. We have aluminum oxide, ALO. Now again, aluminum is a +3. Oxygen is a 2- oxide. So this is going to be Al3O2. Al3O2. Okay. So now again, we're going to predict product. So we're going to see, is iron stronger than aluminum? So I'm going to pull my table up and see it. So here's iron. Where was it at? I just saw it. Here's iron. And here's aluminum. Okay, iron is not stronger than aluminum. Iron and aluminum. So iron will not knock off aluminum. This is becoming a pretty easy worksheet. Okay, iron is not stronger than aluminum. Okay, next one is silver nitrate. So AgNO3. Check your charges, so forth. So nitrate is NO3, and it is a 1-. Silver is a 1+, so I do not need any extra charges, plus nickel. Okay, now this is written backwards, but that's okay. We need to see, is nickel stronger than silver? Is nickel stronger than silver? And as I go to my chart, so hopefully yours is better. So I find nickel is here. My chart does not have silver on it, and I don't happen to have the one that I gave you. So I'm just going to do a quick search, and I want to know is, what am I doing? Nickel and silver. Is nickel, and see if silver, there we go. So I found one, and silver is above gold and platinum. It's below mercury. So on here, this one says mercury is the least on this one, mercury says, it says mercury is the least active, but silver is actually below that. Okay, highly unreactive. So silver is very unreactive. Nickel's going to be above it. So nickel is going to knock it off. Okay, so we've got nickel nitrate plus silver. Okay, and so let's look at our charges again and find out what things need to be. And so if we have nickel and nitrate, nitrate being a -1, and nickel. Okay, and so what they tell you is on those, if you have things like nickel and copper, iron, it is the one that is most common. Okay, and so in this case, the one that is most common, nitrate is or nickel is a +2, and that's something we probably need to make sure that you have on your sheets. Okay, so here is our formula. Now, the next thing that you always have to do when you're going to do a net ionic is, once you get your formula written, is you have to be sure you have it balanced. Now, one of the things when you're balancing is, if you have a polyatomic like nitrate, that's always where I would start first. So this tells me I need 2 nitrates, so I'm going to put a 2 out here. Okay, 2 nitrates. Everybody see where that is? 2, 2. And so then I need 2 silvers on that. And then I need 1 nitrate, and so that's all I need. Okay, and so now we're going to go through, and again, this would be an aqueous solution, as would this one over here. And so this would be your solid nickel and your solid silver that it made. So putting our states of matter on it. So now we're just going to break it apart. And so when I go do that, I'm going to have 2 silvers, have a 1+ charge, plus 2 nitrates that have a 1- charge, plus the nickel, which is in its neutral atom. Then I have on here, I have 1 nickel, which is a 2+. I have 2 nitrates, which is a 1-. Okay, again, 2 here, 2 nitrates. And I have 2 silvers. And this one again is your silver with neutral atom, so there's no charge on it. So I've got all that written out. There's my ionic equation. Now I've got to decide if there are any spectator ions, anything the same on both sides. And so in this case, my spectator, hopefully you're doing this on your own paper, because I don't know if you've got room on here if you write very big. But in this case, if you look, your 2 NO3s, so your nitrate ion is going to be your spectator. Your net ionic equation then is going to look like you have your 2 silvers, ions, plus nickel, gives you your nickel plus 2 silvers. Okay, and so that would be your final piece of it with your net ionic and your spectator. Okay, I'm going to do one more real quick. So we'll go ahead and do sodium bromide. So sodium is Na, bromine is Br, sodium is a +1, bromine is a -1. On that, we've got iodine. Now, this will be our aqueous solution. We've got iodine. Now, remember, iodine is your diatomic. So don't forget that I2 in its, actually, it's a liquid at room temperature, isn't it? On that. Not a solid. So then, and if you don't know that, that's fine, but iodine is brown liquid at room temperature. So now we're going to go to our table. Here's the difference in this table. Because I'm no longer looking at metals, okay? Because iodine is over on group 17, it's going to form an anion, okay? An anion. So it's not going to replace sodium. We're trying to figure out, is iodine going to replace bromine? Because look at your periodic table, iodine and bromine are both in group 17. So is iodine going to replace bromine? Okay? And again, it's on your table. You can look at it, but basically it goes according to your group 17. Fluorine is going to be more reactive than chlorine, which is going to be more reactive than bromine, which is going to be more reactive than iodine. So in this case, bromine is more reactive than iodine. Bromine is stronger than iodine. So this one again is going to be a no reaction.